Hi, Bruce Miashti here, and in this set of videos I want to share my perspective on what I consider the main schools of thought that underpin modern process excellence thinking, and to describe how they came about, how they evolved, and how they relate to each other. The first school of thought I call process analytics, and it's characterized by the use of tools, often statistical in nature, probabilistic in nature, simulation modeling, etc. Now, Six Sigma would be one of the famous examples of this school of thought. The second school of thought I call lean flow. Lean, coming from the name that Western academics placed on the Toyota production system when they first started studying that a few decades ago. And flow, I like to use that term because I believe it captures an important characteristic of this school of thought, which is that value-adding activities need to flow without interruption in a stream to deliver value to the customer. Re-engineering is a school of thought that emerged primarily in the late 80s and early 90s, and it consists primarily of the intensive use of information technology and digitized data to design and to manage a process end-to-end. And the fourth school of thought is traditional process thinking, whose origins go back at least 150 years or more. But it's, I think, important to understand this traditional thinking, A, because it's still often used by many organizations, and B, unfortunately, the paradigms and stereotypes of this thinking is partly the big change impediment to improving process today, this traditional thinking. If we go back to the mid-19th century, say around 1850, 1860, we see the origins of the traditional process thinking, although back then it was revolutionary and paradigm busting, ironically enough. I would pick that time frame because that's where we see this incredible innovation and expansion in American industry, spurred by things like the Transcontinental Railroad, by new industries like the oil sector, the telegraph. And they demanded, these industries did, huge volumes of standardized, interchangeable parts. And so this is where you get the paradigm, the stereotype of the process is about manufacturing only, that it's about standardized stamping out of identical widgets, which was certainly true at one point, but it's persisted, unfortunately, to this day. A major historical event that I think catalyzed these methods was the American Civil War, which had enormous demand for armaments. As we move from that century into the 20th century, there are at least three events that I think are pivotal in PE development. One is called scientific management, and this is where thinkers like Frederick Taylor and Frank Gilbreth applied a more scientific, rigorous, measurement-based approach to activities, both general activities in daily life, but also in business. So this is where you see the use of clocks and stopwatches and photography and film to minutely study activities. It's where we get the idea of time and motion study, for example. The second innovation was the large-scale use of the assembly line, which is a tremendous innovation at that time. It's still used today, although, again, sometimes the paradigm of that traditional assembly line has been as much a barrier today as a help. And the third event was World War I, which, like the Civil War, had this catalytic effect on the scale and use of these manufacturing methods and process tools. After World War I believe there's a fork in the road. On the one hand, there's the continuation and refinement of Ford's initial assembly line methods, which would lead eventually to what I would call today traditional process thinking. But back then, there were refinements such as the development of functions by Alfred Sloan at GM, which did lead initially to improvement in the ability to effectively manage larger, more complex organizations, but also led, unfortunately, to the silos and the fragmentation, which is the biggest weakness of traditional process thinking today. The other branch, process analytics, built on the scientific management thinking of Taylor. And so, for example, at the tail end of World War I, around 1917, in both the US with Thomas Edison and in the UK, statistical methods like simulation modeling and probability thinking were used to develop and refine the merchant shipping convoy method to protect them against German U-boat raids. These analytical, mathematical tools continued to be developed in the 1920s by what I like to call the statistical scientists. So people like Ronald Fisher, working in agriculture in the UK, using and developing analysis of variance to perform statistically designed experiments. It's people like Walter Shewhart developing control charts at Bell Labs in the US. It's the development of queuing theory by Agner Erlang. All of these tools helped to design better processes, to make better decisions, and to guide the management and operation of increasingly complex systems. Operations research or management science is the label typically given to this very large body of thinking. It was greatly accelerated in its development during the Second World War because of the increased complexity and scale of that conflict, both in terms of supply chains, the large scale of the theater of operations, and the greater complexity of military operations, such as trying to determine how best to intercept enemy aircraft using developments like radar. Also was the need to instill quality control and management on an enormous industrial undertaking, and so you saw the development of quality methods and approaches by people like Duran and Deming. All of these things coming together in the 1940s in World War II.